This is what is going to be going to space for our first demo of our technology.
I've dropped it.
Welcome to the world of tomorrow, where innovations don't just shape our future, they define it. Today, we're diving into a realm where the challenges are immense, the stakes are high, and the potential rewards are nothing short of extraordinary.
When dreams take flight and visions grow, a world of wonders yet to
Join us as we explore a groundbreaking idea that could revolutionize the way we treat some of the most devastating diseases known to mankind. But before we embark on this incredible journey, we have a special request. If you're as excited about the future as we are, hit that subscribe button and become part of our mission to uncover the latest and greatest advancements shaping our world. Your support means everything to us, and together we can continue to bring you the most captivating and informative content.
There's no way of doing this on Earth. You can have things like vomit comets, which I really want to go on, or drop towers, but that only gives you a few seconds of microgravity.
Our story begins in the heart of London, where a new space race is underway. No, this isn't about who can launch the most rockets or send the first person to Mars. This race is about pushing the boundaries of scientific innovation and tackling some of the most pressing challenges facing humanity. At the forefront of this movement is a group of trailblazing startups, and one company in particular stands out.
They can take weeks to months to grow, depending on the drug. Now, this all might sound a bit sci-fi, but this so-called supercrystallization process is based upon decades of research.
This company isn't just dreaming about the future, it's actively shaping it. Their mission is nothing short of audacious: build the world's first pharmaceutical factory in space. You heard that right, a fully functional drug manufacturing facility orbiting our planet. But why? What makes this endeavor so groundbreaking, and what challenges lie ahead for these ambitious pioneers? To understand their motivation, we must delve into the fascinating world of microgravity. As we all know, gravity is a constant force in our daily lives. It keeps our feet firmly planted on the ground and dictates the behavior of objects, both large and small. But what happens when we remove this familiar force from the
This is
equation?
our payload. This is what is going to be going to space for our first demo of our technology.
I've dropped it.
Enter microgravity, a near weightless environment that offers a unique set of conditions unlike anything we experience on Earth. One of the most significant advantages of microgravity is its ability to enhance the efficiency and quality of certain chemical processes, particularly those involving protein crystallization. Proteins are the building blocks of life, playing a crucial role in virtually every biological process in our bodies. They are essential for everything from catalyzing metabolic reactions to transporting molecules across cell membranes. But proteins aren't just vital for life, they are also key players in the development of new drugs and therapies. Understanding the structure of a protein is paramount in the pharmaceutical industry, as it allows scientists to design drugs that can interact with them more effectively. However, studying protein structure is no easy feat. And here is where microgravity comes to the rescue.
If I don't break it, this lab in a box is destined for the International Space Station next month.
In Earth's gravity, proteins tend to form irregular shapes due to the constant downward pull. This irregularity makes it challenging to analyze their structure and hampers our ability to develop targeted therapies. But in the microgravity environment of space, proteins have the opportunity to form more ordered and symmetrical shapes. This increased order makes them easier to study and opens up new possibilities for developing life-saving treatments. One of the most exciting applications of protein crystallization in space is in the field of cancer research. By understanding the structure of proteins involved in cancer development, scientists can design drugs that target these proteins more effectively, leading to better treatments for patients.
The long-term vision is that BioOrbit has its own space station filled with these manufacturing lines, just constantly churning out these crystals and then bringing them back down to Earth.
For example, a drug called Herceptin has been developed to target a protein called HER2, which is often overexpressed in breast cancer cells. When HER2 is overexpressed, it sends signals that tell the cells to grow and divide uncontrollably. Herceptin binds to HER2 and blocks these signals, slowing down the growth of cancer cells. Another drug called trastuzumab targets the same protein. It combines an antibody that binds to her to choose a toxin that kills cancer cells. These drugs have revolutionized the treatment of certain types of cancer and have improved the survival rates for many patients. So the potential applications of microgravity-enhanced protein crystallization are vast and far-reaching. It is no wonder then that companies are investing heavily in developing new technologies to harness the power of space. But how exactly does this translate into a thriving space economy? The space economy encompasses all economic activities related to space exploration and utilization. It includes everything from satellite communications and Earth observation to space tourism and resource extraction. In recent years, the space economy has been on a rocket trajectory fueled by technological advancements, increased private investment, and a growing demand for space-based services. One of the most significant contributors to the growth of the space economy is the commercialization of space travel. Once the domain of government agencies and wealthy private individuals, space travel is now open to a wider audience.
There's quite a bit of red tape here.
We might be in a situation where auditors have to come to space as an astronaut themselves to audit our factory, which is definitely a job that I think people would sign up for.
Companies such as Virgin Galactic and Blue Origin are offering suborbital flights to space enthusiasts, providing them with a taste of weightlessness and breathtaking views of Earth. These experiences are not cheap, but they are becoming more accessible as the industry matures and competition increases. Another driver of the space economy is the growing demand for Earth observation data. Satellites equipped with advanced sensors are providing valuable information for a wide range of applications, including agriculture, forestry, and disaster management. For example, farmers are using satellite imagery to monitor crop health and optimize irrigation, while forest managers are using LiDAR data to map vegetation and detect changes over time.
To quote Captain Kirk, space, the final frontier, could be closer than you might think.
This trend is only expected to grow as the need for accurate and timely geospatial data increases. In addition to these factors, the space economy is also benefiting from several technological advancements. The development of reusable launch vehicles has significantly reduced the cost of accessing space, making it more feasible for commercial ventures. Moreover, innovations in areas such as propulsion systems, materials science, and robotics are opening up new possibilities for space exploration and utilization. So, what do these developments mean for the future of the space economy? Experts predict that the industry will continue to grow rapidly in the coming years, driven by factors such as increasing global connectivity, the rise of the gig economy, and the growing importance of Earth observation.
Startups like Space Solar is one of many racing towards the space economy, a commercial sector projected to reach $1.8 trillion in the next decade. We're already turning to the stars for holidays with tour operators like Virgin Galactic and Blue Origin.
Is this wild?
By 2030, the space economy is projected to reach an astounding $1.8 trillion, up from just $427 billion in 2021. This growth will create new opportunities for businesses, governments, and entrepreneurs alike, driving innovation and economic activity in the space sector.
Stay on Earth, reach for the sky. No limits here, just dare to try. Welcome aboard, explore, create. The future's ours, let's innovate.
So the future of the space economy is bright, but it also comes with its fair share of challenges. One of the biggest hurdles is the high cost of doing business in space. Everything from launch services to satellite maintenance is expensive, which can limit the profitability of commercial ventures. Additionally, the harsh environment of space poses significant challenges for spacecraft and equipment, requiring robust and reliable systems to ensure smooth operations.
But also for farming. Interstellar Lab is developing biospheric pods and microgravity greenhouses to grow life in space. And one day soon, the atmospheric conditions of space could help better our health. According to the World Health Organization, 1 in 6 of us are dying from cancer.
However, these challenges also present opportunities for companies that can find innovative and cost-effective solutions. By developing new technologies that reduce the cost of space operations, companies can unlock new markets and drive the industry forward. As we look to the future, it's clear that the space economy is poised for incredible growth and innovation. With the emergence of new players, technological advancements, and expanding applications, the possibilities seem endless.
Currently, for cancer treatment, we have to go to hospital and we get the drugs injected into our veins, which takes a really long time and means we have to spend a whole day in hospital. But if you take the same drug and form it into something that you can inject yourself, now you don't need to go to hospital anymore and you can stay at home. And we're trying to make that happen, because a thing that can make that happen is through making crystals of the drug.
Ooh, crystal.
Whether you're an entrepreneur looking to capitalize on new opportunities or simply someone fascinated by the future of space exploration, the space economy has something for everyone. So keep your eyes on the stars and your mind focused on the future, because the best is yet to come for those who dare to dream big and reach for the stars. Thank you for joining us on this incredible journey through the world of tomorrow. If you're as excited about the future as we are, don't forget to subscribe to stay updated on our latest content. Until next time, keep reaching for the stars and never stop exploring the boundless possibilities that lie ahead.
There's no way of doing this on Earth. You can have things like vomit comets, which I really want to go on, or drop towers, but that only gives you a few seconds of microgravity, and that's not long enough for the crystals to be formed.
They can take weeks to months to grow, depending on the drug. Now, this all might sound a bit sci-fi, but this so-called supercrystallization process is based upon decades of research.
So this box is our payload. This is what is going to be going to space for our first demo of our technology.
Oh, I've dropped it.